Good morning, guys. I just set it up, but good morning, everyone. If you can take your seat, that would be great. Thank you for joining us this morning. From my side, it's early morning. I'm Gilad. I'm managing the HPC Advisory Council. Sydney at the back, she's going to help us to run the next 2 days. Whoa. Sorry that I'm touching the mic again. Here we start. So this is the second time, right? We are here in Australia. We're happy to be in Australia. I kind of landed midnight, and apparently there were more custom people at the airport versus the number of passengers that went off the airplane. So it was funny to be stopped once, twice, and then when we stopped third time, I was traveling with Shainer, which is helping the HPC Advisory Council activities in APAC. We just came back from Singapore. We had the announcement of the HPC University competition. So we were stopped the third time. We were asking if we were traveling together. So I said, yes, can't you see that we're twin brothers? He's Chinese, just so you know. But she didn't have a sense of humor. So we were sent out to the special line. And we were questioning what we're doing here, what we do here. Can we prove that there is a conference, actually? And then can we prove that we are presenting at a conference? How many people are attending? And then when he took the blue gloves and put it on his hands, I said that I hope that that's not for me. Gladly, he had a sense of humor. So after 30 minutes, we were out. Then we were walking out. There was a huge line of people that was just waiting for the regular custom check-in. So actually, those 30 minutes were faster than anyone else. Anyway, good morning, guys. Happy to be here for the second time. Definitely coming from the weather of Singapore, coming here, it's a huge relief. So, a little bit about us. And before starting a little bit about us, I want first to thank the sponsors that help us to conduct the next 2 days. First, I want to thank Pawsey for the great partnership here. So we did the first conference here last year. This is the second time we're doing it here. Without the collaboration with Pawsey, that would not be possible to do. So that's my first thanks, great appreciation. Second, I want to thank the sponsors. So the sponsors, greatly help us to put those kinds of events and without the need to charge people and so forth. They do have tables outside where you're going to have the coffee breaks and so forth. So please do visit our sponsors. I also want to thank Dan Olds. So Dan is going to videotape all of the sessions here, and we'll post them after the conference on the website. So you can, if you missed anything, you can see that at the recap. So a little bit about us. The HPC-AI Advisory Council was established in 2008. So we're celebrating our 10th year. We built that non-profit organization in order to help drive more HPC and AI adoption, usage, understanding, technology experience, and so forth. We have more than 400 member companies, universities, research centers that are members around the world. And we're doing multiple things. First is that we do operate a benchmarking center, a compute center, that does host the latest and greatest from a CPU, from networking, from storage, and so forth. That center provides us the means to run a lot of best practices and to do our publications. But we also provide free access for people to connect from the outside, to do their own testing, their own evaluation, development, and so forth. So if there is a need to look on differences of compute platforms, CPUs, GPUs, networking, storage, and so forth, you're more than welcome to visit the website and see the information there. We're also doing conferences around the year where we're trying to bring different kind of topics to be able to have live discussions and so forth. We have 2 more conferences this year. So next one is in Spain in September, and then we have one in October in China. And last and not least, we're also managing 3 competitions around the year. We have the student cluster competition that we manage that happens at ISC in Germany. There is an RDMA programming competition that happens in China, and then there is the HPCAC-AI and HPC student competition that is done together with NCCS from Singapore. On those 3 competitions, we haven't had, I don't think we had a team from Australia, and that's a pity. So if there is any folks that can think that they might be able to gather a group of students to participate in any of those competitions, just approach me and I can provide you more details about it. It's a great experience for students. It gives the ability to learn more about HPC, how to use it, how to run things, how to install, build your own infrastructure, and so forth. My job within the council is actually to put all of the logos of all the members on one slide. This is what I do. So there is more than 400 logos here. When we moved to format of 9:16, kind of there was more space to put more logos. So made my life easier. Essentially all of the major OEMs, ISV, IHVs, universities, research centers, supercomputing centers, and so forth. And we were very proud to have them all. I mentioned the compute center. This is just few examples of what's there. We have system based on the Intel CPU and AMD and ARM and Power, different kind of networking, storage, and so forth. And again, if there is a need for access, testing, and so forth, you're more than welcome to send in a request through the website and you get free access to the systems. We also operate or run a community which provides a lot of best practices and information on installations, optimizations, and so forth of different applications. So you're also more than welcome to check the information being posted there. And a few things about the next 2 days. So the goals in education training, talking about solutions, future technologies, and so forth. We do encourage live discussions. So you don't have to wait for the end of the talks. You can just raise your hand and have a discussion with the speaker. We will try to hold time. So we might need to stop things and have those discussions being done offline throughout the breaks. People that speak and we don't have your slides, it will be appreciated to have your slides before your session. That's going to help us. There is a raffle that we're going to do on Wednesday, so the second day. There is the HPC Council stand just outside of the room. There is a fishbowl there, and you're more than welcome to put your business card or any name card there. We have an evening event at Pawsey today, and there's going to be transportation from here. It's like 20 minutes, give or take. I think you need to just register, so I do encourage you, well, if you're not working Pawsey, even if you work in Pawsey, it might be nice. But to join us this evening, there are going to be some light appetizers, and you can have a tour at Pawsey. And tomorrow we have longer trip event. You have the information on the agenda, and that's a required registration. So if you are interested to go, please do register. With that, I want to welcome you again, and good morning, and thank you for joining us. They're going to be great sessions. I'm looking forward to hear a lot of the talks here. Before we start with the keynotes, I'd like to invite Mark Stickells from Pawsey to say a few words. And again, great appreciation to the collaboration with Pawsey. Without working together, we could have done this event. Thank you very much. And thank you, guys.
So, good morning, everyone. Thank you for attending today and tomorrow's conference in partnership with the HPC-AI Advisory Council and the Pawsey Supercomputing Centre. Firstly, I'd like to acknowledge that the land on which we meet today is part of the traditional lands of the Noongar people and pay my respects to their elders past and present. I also acknowledge the Whadjuk people as the custodians of the greater Wallyup country around Fremantle. As many of you know, Aboriginal communities across Australia use traditional knowledge and fire techniques to manage their environment for thousands of years prior to the arrival of Europeans. However, due to the impacts of colonisation, traditional bush burning largely ceased during the 20th century. But in recent decades, we've seen the reinvigoration of traditional fire management across Northern Australia in particular. These traditional fire management techniques reduce the risk of wildfires and the associated uncontrolled release of massive amounts of carbon dioxide into the atmosphere. They also protect biodiversity, communities and infrastructure, especially in remote areas. So I'm sure you're wondering why I'm talking about fire management in a conference to do with high performance computing. And you're asking yourself that right now. But researchers from Murdoch University have recently applied decades of environmental and climate cycle data through Pawsey supercomputers to model fire risk patterns and profiles in order to predict future fire risks. Enabled by HPC, this research values a longer-term view of land use and fire management, similar to traditional Aboriginal knowledge of country, a knowledge that has been largely discarded by European-based land management practices. In a small way, this illustrates a great deal about the nature of knowledge and how we need to look to alternative ways to approaching problems in an increasingly complex world. So the great environmental, agricultural, medical and social challenges facing the planet in the years ahead won't be solved by doing things the way we always have. New ways of solving require new ways of seeing. And supercomputing is playing a key role in this new data-enabled problem solving and insight. However, has data become something of a problem? Sometimes it seems that data is rapidly becoming part of the problem, not the solution. The unwanted offspring of technologically advanced but unprepared and irresponsible parents. Today, a tidal wave of data threatens to overwhelm us, consuming our attention to its volume and diversity. We are moving from a state of somewhat data deprivation to something of a data deluge. And this data deluge is changing the fundamentals of our scientific approach, from the traditional hypothesis-driven scientific method to science based on exploration. So our researchers no longer simply ask, what experiment could I construct to test this hypothesis? Increasingly they ask, what conclusions can I draw from all this data? Or increasingly we hear, what insights could I uncover if I combine data from multiple disciplines and domains? It's an exciting time for researchers and supercomputing, artificial intelligence and machine learning that are actually front and centre in this new wave of development. The challenge is to analyse petabytes of data on a timescale that is practical in human terms. The square kilometre array, for example, will be one of the world's great scientific endeavours. It will generate enormous amounts of data and will require immense computing power to produce data products that scientists will use to make groundbreaking discoveries. In the build-up to this incredible project, Australia has invested in two precursor telescopes, the Australian Square Kilometre Array and the Australian Square Kilometre Array Pathfinder and the Murchison Wide Field Array. From the remote Midwest region of WA, data flows 800 kilometres to Perth, where it is processed in a powerful supercomputer called Galaxy. Galaxy takes this data and converts it into science products, images and image cubes across a range of wavelengths and frequencies that scientists across the globe can use, analyse and study to make their discoveries. But data is impotent without strategy. Or to put it in commercial terms, data itself does not have intrinsic value without the analytic filter that points towards discovery. The collaboration between science and industry, between data harvesting and value creation is crucial. As Gordon Bell reminds us in the introduction to Microsoft's The Fourth Paradigm, it was Tycho Brahe's assistant, Johann Kepler, who took Brahe's catalogue of systematic astronomical observations and discovered the laws of planetary motion. This established the division between the mining and analysis of captured and carefully archived experimental data and the creation of theories. So what is Pawsey and what role does it play? The primary function of the Pawsey Supercomputing Centre is to accelerate scientific research for the benefit of Australia in domains including astronomy, bioinformatics, medicine, energy and resources, artificial intelligence and more. Based in Perth, Pawsey is operated by a consortium of 5 organisations: CSIRO, Curtin University, the University of Western Australia, Edith Cowan University and Murdoch University. Pawsey itself is one of many facilities within the National Research Infrastructure and a flagship facility of the National Collaborative Research Infrastructure Strategy. And in April, the now former Prime Minister announced an additional $70 million for infrastructure improvements to enable Pawsey to continue to drive innovation and accelerate discoveries. The 2018 federal budget also set out a 12-year, $1.8 billion National Research Infrastructure Investment Plan, and investments will be guided by a national roadmap that will require co-investment from industry and other sources. Pawsey also receives support and funding from the West Australian Government. So what does Pawsey provide? It provides access to the highest order of peak computing power and to storage capabilities for those that wish to share very large data sets or data sets that require a high degree of collaboration and expert services. So who can access those services? We offer a priority allocation for people within the radio astronomy community, as we support and look forward to the Square Kilometre Array arriving in Australia in the next decade. We also have merit-based access schemes for the most excellent research that's conducted by universities and research agencies. And we also support government and industry, particularly through collaborations with universities and research agencies. I'm really pleased. I should check what's on the slides. There we go. So you'll see this tonight, those that are coming to the Supercomputing Centre. And hopefully there'll be some blue skies through the day. And another one. So what I'd like to just illustrate is a couple of Pawsey case studies just to show you the type of exciting work that's been enabled by our centre. So one of our projects is to help improve Australian maritime safety. So ship groundings account for 1/3 of the world's maritime accidents and can be catastrophic for maritime operations, humans and the environment. Pawsey Supercomputing Centre has assisted Hydraulic Specialist Group DHI in the creation of a preventative strategy. The complex modelling system supports the improvement of emergency response strategies at sea. We're also working in the area of energy and in tidal energy in particular. So for the last decade, Carnegie Clean Energy has been developing a wave energy device that converts ocean swell into zero-emission, renewable power and desalinated fresh water. So off Garden Island, just a little south from here, Carnegie's main device is currently in use helping power Australia's largest naval base. Taking the device from a research project to widespread global commercialisation requires an understanding of the complex physics of waves. And Carnegie works with researchers at the University of Western Australia, utilising the supercomputing power of Magnus, our flagship system, to better understand the impact of wave energy and thereby help Carnegie validate the next generation of its device. We also, although you might think of Perth being a wet city based on our rain overnight and some of the rain we've had in the last month, Perth is actually quite an arid environment, and we rely heavily on aquifer sources of water. So we've relied very heavily on that to meet our water demands, but over the last 30 years, aquifer recharge in Western Australia has reduced. So with the help of Pawsey, a team from Curtin University has helped create detailed 3D models of Perth's groundwater aquifers by sending airborne electromagnetic survey measurements directly to our supercomputer for near real-time data processing. And these models help our Department of Water recommend extraction sites and improve the management of these facilities. Pawsey's supercomputer is also cooled by aquifer water, and we recharge 21 million litres of water each year, extracting from the aquifer and recharging it each year. And my final case study is one in this growing area around health. And the headline is Protecting the Lives of Premature Babies. So we're collaborating with a team from the Ontario Institute of Technology in Canada, where they've developed a system that supports the acquisition and storage of patients' physiological data and provides those streams and clinical information for real-time analytics and retrospective analysis. And this platform doesn't require a local installation as it runs using cloud services and supercomputing hosted by Pawsey, allowing a live stream and analysis of around 1,200 data points per second per patient. So in all of those projects, the role of industry is a key one. And these really point to a main point of my discussion today, or my introduction. It's a fundamental role of industry in realising the benefits of research and discovery. Now, for those of you that don't know me, and most of you in the room don't know me, I've only been the Executive Director at Pawsey for a few weeks. I'm approaching 2 months, and this is my first role focused specifically on high-performance computing. But I have a long background in working in research and the innovation ecosystem, most recently at the University of Western Australia and the WA Energy Research Alliance before that. And a key part of my working life has been connecting industry with researchers to tackle some of the big commercial questions of the day. Being predominantly based in Perth, many of those issues and many of those companies have focused on the energy and mining sector. And in my previous role, I was at UWA, I was the Director of the Energy and Minerals Institute. So over a decade, we ran a number of successful projects and collaborations between industry and the research sector and generated over $100 million worth of investment in that area in new research and facilities. One of the areas that I worked in was also to develop an innovation platform, an industry survey called State of Play. And since 2012, we've done a regular survey of mining and other industries to investigate the development of innovation strategies and applications in their sectors. And one of the strong lessons to come out of those surveys showed that when it comes to innovation, it's actually less risky to be an early mover than it is to wait, as long as you have a structured framework for implementation. To wait sometimes may seem the safer option, but by then the market is often overcrowded. Conservative followers also tend to have an unsupportive corporate cultural environment for innovation implementation, which leads to poor outcomes. And often innovation doesn't come from big companies, it's the smaller end of town, startups and researchers where innovation typically emerges. We therefore need meaningful ways to connect these innovators with the bigger players and facilitate ways to collaborate. And the lessons for big companies is to support this process as they are likely to benefit directly from the innovations that emerge. I'd also like to comment on diversity. I think innovation and conversations around diversity go hand in hand, whether that's increasing women in the workforce or improving access to young people to pursue careers in the computational sciences or data-fueled industries of the future. And in my first few weeks of working in this sector, the HPC world clearly talks a lot about scalability and parallelisation, and it's a focus on the hardware and software that makes our impressive facilities run. Yet my first impressions are also of the power of the people in this sector, and that's that we're actually going to need a lot more of us. When I actually reviewed Pawsey Centre's staff list, and there's several of our colleagues here today, it surprised me to find that 13% of our staff were actually called Mark. Now, I think Mark is a fine name, and I'm including Marco in this as my Italian colleague, as a Mark, and I'm glad that my parents called me Mark. It's easy to spell. But the high number of Marks at Pawsey says as much about the lack of imagination in my parents' generation when it came to name giving, as it does reflect a lack of diversity, and especially in women working in our area. So like our access to other types of knowledge to improve environmental outcomes through the use of Aboriginal fire management techniques, so it is that women bring a different perspective to our search for meaning and problem solving. And likewise to researchers from different cultures whose heritage is different to my own. We need varied perspectives to enlarge the discovery bandwidth that we're all a part of. Now, Australia's discovery legacy is actually quite a positive story to tell, and I appreciate the opportunity to reflect on this. The boomerang, the stump jump plough, the wine cask are all famous Aussie inventions which improve the lives of thousands. Perhaps not the wine cask, but we have other innovations that I think we reflect from ingenious Australians. The medical application of penicillin, the black box flight recorder, and for anyone that's travelled, I hope that technology is not applied for you on your return travels. The electronic pacemaker, polymer banknotes. So the fact that we actually license the banknote technology to other countries around the world is a great reflection of licensing printing money. Fantastic. But the research for that innovation began in 1968 following a request from the Reserve Bank of Australia for a scientific solution to combat forgeries of this new national currency when we created decimal currency in Australia in '66. CSIRO's solution was to have a see-through panel and hologram embedded in the note and to use plastic. In addition to their inability to be forged, the new notes were also more durable, more environmentally friendly and less likely to carry dirt and disease. Also, the now ubiquitous Wi-Fi came out of CSIRO's pioneering work in radio astronomy. That work involved complex mathematics as well as detailed knowledge about radio waves and their behaviour in different environments. And interestingly, about 60% of global mining software is developed in Western Australia and Greater Australia. So there is no question in my mind that we have great bench strength when it comes to technology and innovation. And as our now former Prime Minister championed, we are an ideas nation, but we definitely need to up our game when it comes to the commercialisation of our discoveries. So as I conclude, I'm learning that a lot of influential people outside of our industry don't understand the role of HPC in our research and innovation ecosystem. Pawsey is a bit of a hidden asset, but I'm determined to make more people aware of Pawsey and the great research that it enables. Rarely are modern innovations the product of an isolated, solitary genius. Typically, it's through the intersection of different industries that interesting breakthroughs happen. Hence the importance of engagement and collaboration. It's critical to bring industry, researchers and our experts in HPC together. Forums such as this share the expertise and insight across industry sectors and domains, and they are vital. So in concluding, I'd like to thank the team at Pawsey and all of my colleagues who have supported this event. And again, welcome to all of our visiting delegates from around the country and across the world. Welcome to Western Australia, and I hope you get the opportunity to see some of the city and greater surrounds while you're here. The weather hopefully will improve. I understand we have more storms tomorrow. Unfortunately, I'm going to miss tomorrow's program because I've been invited to travel to the Murchison on what I understand is a very small plane, so I'm watching the weather with some interest. But we're visiting the Murchison radio astronomy site with the CSIRO board tomorrow. So thank you very much for attending today, and have a great conference and engage with your colleagues. Well, I look forward to seeing you this evening at the Pawsey Centre, and enjoy the next 2 days. Thank you very much.